Hello, and today we'll be solving problems involving current resistance and resistivity. So let's start with this sample problem. The electric current in a wire is 6 amperes. How many electrons flow past a given point in a time of 3 seconds? So let's first write the given. So we have a current I of 6 amperes and a time or change in time of 3 seconds. Then we write what we're looking for or the required in the problem, which is the number of electrons passing, or we symbolize it as N, capital N. Then we write the equation. First, we know that current I is the ratio of charge over time. So from this formula, we can get delta Q, or the charge, which is equal to I times delta T. But delta Q is also equal to Ne, where N is the number of electrons passing through a cross section area, and E is the number of or the charge of an electron with a unit of coulombs per electron. So in short, 1 electron is equal to 1.602 times 10 raised to negative 19 coulombs. And from here, substituting this into this and solving for N, we will get that delta Q over E is the same as I times delta T over E. Now we will substitute everything that we have. So we have a current of 6 amperes, change in time of 3 seconds, and E is always 1.602 times 10 raised to negative 19 coulombs. From here, you can see that the units will cancel. Remember that ampere times second is the same as, or the unit ampere second is the same as unit coulomb. So these two would cancel, and we will only be having electrons as our unit, since that is what we're looking for in this problem. Substituting it in your calculator, you will get 1.12 times 10 raised to 20 electrons. Okay? Rules on significant figures are suspended in these sample problems. So our answer would be 1.12 times 10 raised to 20 electrons. For number 2, for number 2, a number 12 gauge copper wire commonly used in household wiring has a diameter of 2.053 millimeters. There are 8 times 10 raised to 28 conduction electrons per cubic meter in copper. If the wire carries a constant DC current of 5 amperes, what is the drift speed of the electrons? So first we write all the given. We are given with a diameter of 2.053 millimeters. So we convert that to meters, which is 2.053 times 10 raised to negative 3 meters. And you are also given with N, which is the conduction electrons per cubic meter in copper, 8 times 10 raised to 28. The current I is 5 amperes, and E is always equal to 1.602 times 10 raised to negative 19 coulombs per electron. We are looking for the drift speed of the electron, or V sub d. Since it's speed, so we're only concerned with the magnitude, V sub d. Our equations, so we have this mother equation, I is equal to the relationship between the current and the electrons passing through a cross surface or cross section area of the wire, which is I, or the current, is equal to NEA V sub d. V sub d here is the drift velocity. And remember, since the area is of circle through the wire, so area of the circle is pi r squared. But r is equal to, or can be written as 1/2 of the diameter, so d over 2. And simplifying this, you will get the area in terms of the diameter as pi d squared over 4. You can use the following relation. Either of the following relation would work. Now, since we are looking for the drift velocity, we just need to plug in that area into this, and you will get this one. So that would be the formula for the drift speed. Substituting everything that we have, so 5 amperes is your current. This one is your N, conduction electrons per meter cube or cubic meter, and E, and your area, which is this one, d squared over 4. Plugging it in your calculator, that would yield an answer of 1.179 times 10 raised to negative 4 meters per second. Make sure that your units agree with each other by converting every given into its counterpart na SI unit. Alright, so let's proceed to number 3. So for number 3, what length L of copper wire is required to produce a 4 milliohm resistor? Assume the diameter of the wire is 1 millimeter and that resistivity of copper is 1.72 times 10 raised to negative 8 ohm meter. So we write all the given. We are given with R 4 millimeters, or not 4 millimeters, 4 milliohms, which is 4 times 10 raised to negative 3 ohms. 1 millimeter is 1 times 10 raised to negative 3 meters. And a resistivity rho, so that is not P, it's the Greek letter rho, pronounced as rho. That is the R of in Greek. So Greek letter rho, which symbolizes the resistivity of the copper, and is equal to 1.72 times 10 raised to negative 8 ohm meter. So what we are looking for the length of the copper wire to produce a 4 milliohm resistor. So we have this mother equation. From here, we can derive this one. And we can express this area in terms of the diameter. So we get this final equation. R times pi d over 2 squared over the resistivity rho. Okay. So we plug in everything that we have. So this is this one. This one is this one. This is the resistivity. Don't forget to square the radius in terms of diameter. From here, you see that the units would cancel and the only remaining unit would be meters. Plugging it, you will get 0.183 meters. That would be your final answer. So let's proceed to the next problem. For number 4, the resistance of a copper wire is 4 milliohms at 20 degrees Celsius. What will be its resistance if heated 80 degrees Celsius? Assume that alpha is equal to 0.004 per Celsius. So we write the given again. We are given with the initial resistance of, so that's R naught. It's pronounced as R naught, R sub 0, or the initial resistance given is 4 milliohms, which can be converted as 4 times 10 raised to negative 3 ohms at initial temperature of 20 degrees Celsius. So that 20 degrees Celsius is the room temperature. R, or the final resistance, is what we're looking for at final temperature of 80 degrees Celsius, with alpha given 0.004 per degree Celsius. We are looking for the final resistance at temperature 80 degrees Celsius. So we have here the related equation, delta R is equal to alpha, initial resistance, and change in temperature. That change in temperature is equal to final temperature minus initial temperature. Substituting what we have, so you get this as your alpha, resistance, this one from here, final 80, initial 20 minus, okay? Plugging it in your calculator, you will get delta R 9.6 times 10 raised to negative 4 ohms. But this is not the final answer yet, because what you're looking for is R, not change in R, or the change in the resistance. You're looking for the final resistance. And remember that change in resistance is equal to resistance final minus resistance initial. Solving for R, so ililipat mo lang to siya dun sa kabila, mag-a-add siya dito, kaya naging ganyan. And then substitute this one and this one from here. So i-add mo lang yan and you will get 4.96 milliohms. So that's your final answer. So that would be all for your problem set for this topic, current, resistance, and resistivity. On your one whole sheet of yellow paper, write the problems and solve the following questions systematically by identifying the given, required equation, solution, and final answer. Please box your final answer. Here is your problem set. You can pause the video now. Thank you so much for watching, and if you have questions, kindly email me on my email address.